All right, check it out. Today I have a HILTI TE-70 roto hammer. And so I've got it plugged in. It's dead to the world. Well, I know we got power because we have that light that's lit up. So why doesn't it want to run? This thing's definitely been rode hard and put away wet a very few times. Look at that, how crusty it is. Man, it's got rocks and pebbles embedded in there. Well, let's go ahead and get it open and see what she looks like inside. Alright, so I've got it partially apart. I want to check the trigger over here. So I just want to make sure that the incoming AC is connected to the switch. I'll get my meter up here where you can see it. I'm on continuity. That side has connection. It doesn't seem to change. So it looks like they're only switching one side of the line. Go over here to this side. Look at the AC input. We're good there. Let's just see if we get voltage on the output. And we do. Okay, so the switch is switching. So the next thing I want to do is check these three leads, which are most likely the speed pod in here, to make sure the speed pod's okay. So I'll remove power and we'll get my pincher probes and we'll go ahead and pinch these lines and see if we get a resistance swing as we throttle it. So I've got my probes hooked up to 2 to 3 leads. I'm on ohms. I've got 238K. And as I throttle it, I do see it go down to about 200 at one point. Let's go min-max. Oh, that's interesting. It's bouncing all over the place. Max we got was 238.8K and the minimum was 40K. So let's go ahead and move one lead over to the unused lead. Turn off min-max. I'm not seeing a change that I like to see. Just for the heck of it, we'll go one more time. Go to the third lead, to the center lead, just see what we end up with here. Wow, I'm really not seeing a change. I think we're going to pull this apart and see what's inside. See if we can get to the bottom of it. So I think that might be what's going on. I don't smell anything burnt, like when one of these modules goes out. This one does have a large control module here, as well as I believe this is what has the FETs in it that drive the motor. So I'm going to pull this speed control apart first before we do anything else. Wow, thing left a mess. So let's get zoomed in here. It looks like it just snaps together. So we'll get it unsnapped and see what's inside there. Let's see how many Springema things will fly out of here. Right off the bat, that does not look good. So here's the wiper for the pot. It just slides down when you squeeze the trigger. So I see there's a third lead in here. I didn't take that into consideration when making measurements. Looks like this is the only one that switches, and we did get good continuity there. So I see this big blob right here. I'm not sure what that is, but it's definitely been running hot over here. Looks like just dielectric grease of some type. We'll get the meter back out and make some measurements. So we'll try to it appears that this is connected to that, but I'm still concerned about this pod over here because we weren't getting the movement that we should as we slid this pod around. So I'm going to wipe off these tracks and do some light resistance measurements with the probe and see what we get. So I'm just going to go to these plate throughs right here. Let's go back to ohms. I'm just going to go from one lead to the plate through. And it looks like we're charging this capacitor possibly. Okay, so that's one end of what looks like the wiper portion of it. This is the constant side. And so this should be the other side. So these two are the actual resistance element here. 46K, and so this one should connect to the wiper, and it's 0.3 ohms. So depending upon where we have these things, if I just touch my meter on here, we should get a low reading, and then as I drag it farther down, the resistance comes up. We were getting 200K, and the most that we should see in here is going to be 46K. Continuity wise, everything checks good. I'm going to go ahead and clean these contacts up and see if this just lifts out kind of easily, maybe. Yeah. Contacts look okay. They kind of just right in here like that. Then as this thing goes up and down, they slide on that. And they activate that switch. Off, and then on. Off, on. So I think I'm going to clean those contacts up and see if we get anywhere. I'm just going to wipe them off. They're awfully grungy. I don't know if I can get them out. Yep. Contacts actually look just fine. I wonder if they were all just grunged up was the big problem. I'm going to snap them back into place, and I'm going to give them a little tiny bit of preload, more than they had. And I'm going to hit those with a little bit of alcohol in the Q-tip, and then we'll apply some dielectric grease and put it back together and see if we get some different results. Okay, so I've got a Q-tip with a little alcohol. I've got the brightness on the camera turned up so you can actually see this here. So let's go ahead and clean that off really good. We'll dry it as best we can. I'm going to do the same thing here. That looks good. So I'm going to take a little dielectric grease here, put it on here and smear it around just a bit. Make sure it's all covered so no air can get to it. And at the same time, I'm going to coat the contacts. Well, let's put it together and do some resistance measurements now. Let's snap her together. Well, it may not be perfect. I can get my probes on here. It's like chopsticks. But you can see as I increase it, it does move up and down now. It's not at 200K anymore. There's a couple bumpy spots in here, but it does increase. So let's throw it all back together and see if we get any different results. Well, unfortunately that did not work. It's still dead. So most likely this control module may be having a problem, but it's potted. So there's really not much more we can do. This is the driver module that has the individual FETs in it that drive the output to the motor. And so I did find a service manual on this unit, and it's labeled number 4 and number 5, and that's with theft protection. And then they have a version without theft protection. Still the same numbers, number 4 and number 5. So when I go over here and look at the cross-reference for number 4 and number 5, not available for customer sale. And in my estimation, that should be illegal in the country. You should not be able to do that. Now, I did find a part number for number 118, which is the trigger assembly that I had apart. So here is number 118, and it makes the contact with the switch, and then this is the pot right here that we measure the resistance on. I believe this is functioning normally at this time, so one of these two items has failed. This has the software in it. It's the computer. This is what does all the power switching. It has the FETs or triacs, as the case may be. I did do resistance checks on the motor. It checks perfectly fine. So I believe the motor is fine. It rotates freely. I even plugged it into a current meter. It doesn't draw any power at all. So anyhow, service manuals are available online. If you know where to look, you can find exploded views of these units. There's the trigger assembly number 118. And so with theft protection, it has the lock on it. Now the lock is not lit on this one, so I don't believe that's the problem. I don't believe it's in theft protection. Nowhere does it discuss how to get it out of theft protection mode. Anyhow, we'll just flash these up here real quickly so you can take a peek at them. If you ever need to freeze frame it, you can look at them real fast. There's some part numbers. There's a couple more part numbers. If this might help you, then feel free to use it. Anyhow, that's the end of this video, unfortunately. If this video has helped you, please consider making a donation on my YouTube homepage with the PayPal donate button, or at paypal.me/NorCal715. Well, hopefully somebody can fix this. It's not going to be me. With your help, we can keep these things out of the landfill and out of the recycle bin. Everybody have a great day. Thanks for watching. Bye-bye.